Hi guys, my name is Igor Zubrycki and I will be presenting about robot fun with ROS 2. I'm from Łódź University of Technology, but I also work at Market Lab. At Łódź University of Technology, I do robotics and professor there, and in Market Lab I lead a group of developers in research and development team. I really encourage you to check my repository and slides. You can find the address here and also I put it on Discord, because the presentation I'm doing right now, as well as the screen that you're seeing on the right part of the screen, is actual Docker container. So you can run exactly the same environment on your own computer, and hopefully you will get the same results. So my goal for this presentation is to encourage you to start playing with ROS and with robots. This is pretty much it, or maybe it is more than that. Because robots are fun to. You can have this many different robots. So, for example, here you have the newest robot from Boston Dynamics. You can see the robot here. The robot is a very fun construction. It looks like a dog without head, so it is actually sometimes called dog. Probably you saw the movies with the prototypes of this robot when somebody was kicking him and being not so nice for him. But from our perspective, so from perspective of developers, you can see that this robot has not only ability to move, but it also has a lot of sensors, and it has ability to plan its movement, to have all this visualization. It can see where it is going and so on. This, what I'm showing here, is actually a new version of this robot, and it is a ROS connected version of this robot. So what I'm talking right now about it is pretty much the same stuff that it is running on this robot. You can also see some completely different robots. So the robots that maybe some of you are more familiar with are these Android type of robots. So here you can see this kind of creepy type of a robot, but it is creepy unless you put a skin on it. So maybe you can see that there is a Mickey Mouse here, because it is actually a robot developed by a Disney research. So there is a group of Disney researchers that create robots for their Disneylands. So probably this will become a pretty princess or maybe some brave hero in a Disneyland. But you can also see that the robot is not only an animatronic device, but there is also a camera, stereo camera, because the Disney research here in this research, they were trying to make a robot that actually his gaze is very active. So my own research is also connected to robots, completely different ones, because they are connected to so-called soft robots. So robots that use pneumatics, use soft materials, and that they can interact with humans. So here you can see our robotic glove. Right now, I'm starting a kind of big project, big scientific project about using this kind of robots in hand rehabilitation for people after stroke. So what are these robots anyway? I showed you different kinds of devices, but what makes a robot a robot? So the definition is quite simple. You need to have motion and you need to... So intelligence is kind of a big word. So let's just assume that what I mean is ability to have some decisions or to make some decisions, and motion, it can be very large range of motion, from walking up to some point of just having some force working on your hand. But the point is that you need to have both, and it is actually quite complicated in practice to make these parts work. For example, there was a big contest about rescue robotics. It was the DARPA Robotics Challenge, and in this challenge, the people were wanted to create robots that can rescue people, for example, in a situation like Fukushima disaster. But actually, you could find many funny examples of these robots, falling over. You can imagine that the robot having something like 200 kilograms and being worth like $1 million or at least a couple of $100,000 is kind of frustrating to see, it falling, but also kind of funny. So it is a difficult subject. Actually, the robots from ROS. So I know that on previous PyCons, as well as in PyCons on different countries, you could play with this simple devices that also are kind of like robots. So you have this mobile platform, and you have Arduino-like or a simple microcontroller board on the top of it. And it is a very basic robot. I would call it a robotic platform. But the question is, what do you do with that? Because its decision-making ability is quite small. You don't have, AI. You don't have too much connectivity. What about sensors? So it is good, but robotics is much more. Actually, robotics, when you think about useful robot, you need to have something about humans, because robots are connected with humans. So you have cognitive science, psychology, design, but also, of course, hardcore technology. So artificial intelligence, not only deep learning, but also, old school artificial intelligence like planning. Of course, you have mechanics, you have a human-robot interaction, and you have robotics-based subjects like kinematics. So it is actually quite complicated to make, useful robot that does the tasks. So is it even possible for, common developer, like normal developer, to play around with robots and to make useful robots? And the answer is obviously yes. The answer is ROS. ROS, like dashing diamond, yeah, there are many different versions of ROS. Usually the sign is some kind of a turtle, so that many robots also have a turtle in the name. But it is really something that enables you to switch from this, small robot with pretty much just an ability to use to go around, to something inspiring, huge, and just interesting to play. Because ROS, so robot operating system, is a lot. It is actually 4 different things that are super useful for developers. You have the tools, so ways to do stuff. You have pipes, so ways to connect stuff together. Developer tools, so the ways that you can make your own tools and stuff, and community. By this, I mean that you are given something that can be the basis of your own cool robot. Like you start from something that is already interesting, and then you put something that interests you or interests your company, because many of us want to make money from it. But the point is that you don't start from zero, because starting from zero in robotics is super difficult. But starting from something more, from something like ROS, is fun. So I will be talking about ROS 2, so second version of ROS. It's actually much better to show something about, because both ROS and ROS 2 are still being developed. But ROS 2, I think, for Python developers is better. From the perspective of Python developers, what is for sure important is, so the code base is much better organized. It is much more, I would say, modern. So, for example, the way that asynchrony works on ROS 2 is something that, advanced programmers of Python are familiar with. Also, just wait a moment, I will switch this off. Okay. Also, from the perspective of people who want to make interesting and useful robots, it is good to know that ROS 2 is much safer, both from the perspective of security as well as from perspective of just general safety. Safe enough that, for example, some German companies are in the process of having self-driving cars based on ROS that will have some license, to be used on streets. So if you want to have like the simplest idea of ROS, it is an enabling tool that enables you to stand on the shoulders of giants. So you do not need to start from zero. You start from good common practices and from good core. So I hope you are interested. So how exactly do you start with ROS? I suggest that you start by setting up your own system in a way that enables the best learning and having most fun during using it. So in my experience, it is much better to set up an interactive system. So robots are like living things. You want to interact with them in a way that you do something, the system does something, you do something, the system does something. So especially during some basic experimentation, you want to have interactive system. Interactive like Jupyter. You want to actually to work in simulations. So while real robots are fun, they are kind of, I would say, scary in a way that you need to maintain everything in the same time. It is quite difficult, and by using simulators, you can focus on one thing at the time. I also suggest you that you use ready-made tools and packages wherever possible. What I mean by that is that, for example, I know some developers, some really brilliant people that take on some really difficult robotics tasks. So, for example, you have something called inverse kinematics. Inverse kinematics is the problem that you want to put your robotic hand in some particular position, and you want to know how much the motor should move. And while it seems possible to do, it is really very difficult problem to solve. And I know that some people, for example, take really long time to solve this problem, but in a ROS, it is just a matter of using a special package. And the package is free. It is readily available. You can use it, even with the system I show you today. Also, even if you want to work on like a big project, so maybe some of you want to work on self-driving cars or robots like Spot. I suggest that you start from toy robots and toy examples, because really, I will show you that the interface to a big robot and interface to a small robot is pretty much the same. Sometimes functionalities are similar. The quality is different, but functionalities are similar. But the price of the robot and like the whole background is totally different, and it is much easier to learn on toy robots. So even a team from Poland that was developing a self-driving cars, they asked me for consultations, and I suggested buy cheap robots, like 1,000 euros, and you will have much more fun than working on, your big car. Because when you have a bug, your small robot will drop and your big car will disappear. Also, use forums, because many issues in robotics are completely non-obvious for developers. But you can actually find people who will help you with that. So in this way, you can start having fun first and worry later. When you are ready to go to big robots school, you can graduate and go there. So how do you start with ROS tool? The most, I would say, difficult way, but the one that you need to do if you want to start robot, you want to start your system on the robot, is to actually natively install ROS on your system. With ROS 2, it is available both on Linux, Windows, and Mac systems. But ROS 1 was only available at Linux. I do not recommend this for starters, because the installation takes quite a long time, and it is just frustrating. Please first start to have fun, and then switch to having something difficult. There is the ability to use VirtualBox, and it is a good idea, but actually VirtualBoxes with ROS usually take quite a large, the files become quite big, and for example, you cannot share this the way you can use containers. So what I suggest is that you use containers. During this presentation, I will be using a container that I created especially for this talk. This is container that you can see on the right. It has actually a graphical system, so it works like a virtual machine, but it's actually a container. It has all of the tools that are good for the beginners already installed. But even if you don't want to use that, I still suggest that you use containers. So for my container, what you need to do is you need to clone my repository. Then if you have Docker and Docker Compose installed, it is a matter of putting this, so Docker Compose up, and in the next terminal, you need to put this command. Actually, I even put a make file now, so it's just a matter of putting two makes, one up. So when you do this, you will have these two windows. One of the windows will be for the virtual environment, and the second one will be for the Jupyter Notebook. So this Jupyter Notebook that you can see on the left is actually connected to the container on the right. So let's start running some robots. So actually, when you want to start running some robots with ROS, you will usually need to start a lot of terminals. So you will start this terminal a lot of times. And I really, it is fun to do. You can actually recognize people who use ROS because they have like 3 monitors, and these monitors are filled with terminals. During this talk, I will be just starting terminal from Jupyter because it is like the lazy man way to do this. So let's start terminal. Hopefully it starts. And with these two commands, you have two terminals. In one of these terminals is this cute turtle. And in the second one, there is teleoperation of this turtle. So actually, by using arrow keys, I can move the turtle around. So this is the way that we already started the ROS system. And in this ROS system, you have these two so-called nodes. So nodes are separate programs that run and are connected with some kind of a ROS interface. So this is a turtle sim node, and this is turtle teleop node. But we are on a Python conference, so it would make sense to control the robots from the Jupyter. So to control this kind of a robot, and pretty much any robot that has like wheels or that can move around, so-called a mobile robot, you need to use a so-called. So the twist command is a command that pretty much says to the robot that please move in a straight line with a particular speed, and please rotate with particular speed. So actually, you send 6 informations, with these six commands, you have all the information needed for the robot to move. So from the terminal, what I'm doing is actually this node sends to this node these 6 informations. I hope you can see everything, but right now the most important is whether the robot is moving or not. I do not hope that you can see what is on the right, because it is just some terminal information. So don't worry if you cannot see. The most important part is that there is a turtle here. Okay, so for us to move this robot, we are going to use an interface called topic, and we are building a publisher. The publisher will be sending a topic, so particular message to a specific topic. So we will be building this guy, and our subscriber will receive this and move itself. To do this in ROS, we are actually first we are using a ROS node. So we will be using an object of type node and creating our own class called turtle mover. In this class, we will have a publisher. This publisher will prompt the Jupyter environment, but we can also use a method called moveTurtle. So in this, we just defined the object here, but with this command, we are actually converting our Jupyter notebook to a ROS node. And with the next command, we are putting in this ROS network, we are putting our Jupyter, our node. So what is left now is just to send a command. The command is kind of simple to build. You are using an object type message twist, and in this object we are setting, please move the robot with X with a speed of 1 and rotate it around with a speed of 1. So with this command, our little guy is rotating around. So I hope you can see that at least it is rotating around, and we can continue and build like some shape. From that point on, we can send a lot of commands. So right now we are putting just one command at the time, but even from Jupyter, so maybe first let's see that our node is there. There is a special program called RQT-Graph, and in this RQT-Graph, this is pretty much, I hope that something is visible. Here we have our little turtle. Here is the node for the teleoperation, and here is us. So both we and the teleoperation turtle are sending command velocity. So the message to the topic turtle1 command velocity. So actually we can send a series of messages to have some particular behavior. We will be making shape. So what it means is that every second we will be either going we will be setting the linear velocity to 1 or angular velocity to 1. So we have these two options. And we will be doing this every second. So this time we are creating a timer, and in this timer we will be putting the make shape, we will be starting the make shape method. So this is kind of a hack because we already created the object. So to the object instance, we are adding another method. So even though we added a timer, nothing is happening because actually we need to start spinning. So by spinning, I mean that there needs to be, the event loop started. So when I'm starting the event loop, you can see that the robot every second it is either going in a straight line or it is rotating. What is interesting is that the event loop starts the behaviors in an asynchronous way. So there can be a lot of going on during the event loop. The problem is that you have to interrupt this loop if you want to change something. So what I did now is that I interrupted the loop. So continuing, because the next time we start the loop, there will be still a timer running, so we can stop the timer. And then we can continue with some other stuff. So our little robot only reacting to messages, but it can also send us stuff. So he is publishing his own pose. So his own position and orientation by creating our own callback that will react to this information. We are creating so-called subscriber. So we are a subscriber to a particular topic. This topic is called turtle1 pose. Every couple of milliseconds, the robot is sending its own pose. And we will be reacting to this. So first we create the subscription, and in the subscription we are saying, if there is a new topic, please run this function. And we need to start the event loop again. And you can see that there is really a lot of this information. Because the robot is sending so much information, it is very useful for us to receive the robot position every millisecond or so. We can actually measure how much information is being sent by using this tool. So this is something that measures the statistics of a topic. And this topic, so turtle1 pose, is sending one information around 100th of a second. So we can use this information to send back a command for a robot. So now we are sending the information back to the robot. We are reading its position, and with this code, we will have something connected to a wall avoider. So what is happening here is that the robot is receiving the position, and if he's near the wall, it will try to avoid the wall. It is failing, so it is a challenge for me a challenge for you to create a better behavior, because right now you can see that the robot is saying to us, "Oh, I hit the wall." So it's pretty much hitting the wall all of the time. But you can play around with this container and change it to your own pleasure. Okay. So actually in ROS2, because it is still in the development phase, I did not find a way to remove a callback. So I will just be changing the callback to an empty callback. So right now, everything up to this point was possible using a simple Arduino-based robot, so like a super simple robot. But what we as a developer want, we want to have some kind of abstraction. So instead of sending just a message, we want something from the system. And we can use something called actions. Actions are much better developed in ROS2 than in ROS1. Action, the robot has its own action to not only move, but also to change its orientation to a particular way. And the interface is quite similar. We are creating an object of class action client. This object will be a what we will be sending is we will be sending a goal to go to the 45 degrees angle. So right now we are using the action in a super simple way. We are just asking the robot, please rotate to a particular angle. But actually, as developers, we probably still want to understand what the robot is doing. So for example, we want to be updated on whether the robot is doing well or bad. We want to have some kind of a feedback. So it is quite a long code to do this. What the code does is that I'm creating a couple of callbacks. And in this callbacks, so what will happen here is that first we are asking the robot to use a particular callback when there is any feedback from the robot. But also, we are also asking the robot to inform us whether there is a success or failure of a whole action. So nothing but I see that there is still something running. So let me stop here for a moment. I need to switch this off. Okay, so let's just start again. Yeah, actually it was running, but we couldn't see it. But what happened is that we received the feedback. There was information of radians there are, and when the robot succeeded, so maybe let's change the angle to something different. So for example, let's change it to minus 90 degrees. Okay. Is it running? Okay, minus 90 degrees, and we can see that there is a lot of feedback, and the result is that the robot succeeded, and the distance was around 90 degrees. Okay. Okay, so the last type of a communication interface, there is also a database inside of ROS, but I think these are the most fun. It's kind of simple to understand for people who develop programs that, for example, connect to internet services, because it is pretty much just a service. You as a client, you send information and you receive information back. So it is like the most classic approach. In ROS, you can either use it synchronously or asynchronously. I suggest using it asynchronously, so your program does not block when it waits for the answer. The simplest service that there is for this robot is one that changes the color of this line. So I can, here I create interface for this service. So this is a way to connect to this service. And now with this command, I will be sending in asynchronous way information about change the color and width of the pen. And for us to see the result, we will also be moving the robot a bit. So you can see that it changed the color and moved a bit. There actually was an answer. We ignored the answer, but there was an answer, and the answer was empty. So whether it succeeded or not, the answer was just empty for this particular service. Because compared to internet services, where usually you, for example, ask for a time and you receive a time, for robots, sometimes you ask the robot to do something and it does something, but you don't need the information back. So congratulations, you used all of the types of ROS to communication. So yeah, but what about it, right? It was very simple, at least for some of us, it was very simple. And like we are in a long way from a robots, right? But actually no, because with ROS, you use the same interfaces for serious robots and for fun robots or, toy robots. So what you can see right now on a left part of the screen is actually this guy. So this is a robot. Compared to the Arduino one would only have this one level. So this is a level of a motor controller. But what is interesting is that it also has Raspberry Pi, and on the top of that, it has a LiDAR, so-called a laser sensor. And in this simulation of this robot, maybe let's zoom a bit, and maybe let's wait a moment. Okay. On the simulation of this robot, you can see that it sends the laser signals and it receives back the information about position of these different parts. And you can also see that it has a camera. We will be using this camera in our program. And seriously, with the code I show you now, you can run this code either in the simulation or a real robot. So it is the same way to control a simulation, real robot, or a toy robot. If you don't believe me, you can see that there is a publisher. We still publish the twist message. We are still using a similar topic. It is called command velocity. And right now, I will be asking this robot to rotate around with a speed of 1/10 of a radian per second. And you can see that our simulated robot is is rotating. Moreover, the interface for sensors, in this case, this robot has different sensors. It has cameras, so we can run the camera. But the interface is also very similar. The code you see here, it is a code for parsing the information back. So actually, we need to use this camera information to somehow show it. But there is just a normal subscriber, and if I want to display this information, I use the Python display to do this. So you can see inside of the Jupyter notebook, you can see the image from the camera of a robot. It's actually looking right on a wall, but you can see that it is looking on some green wall now. Okay, so let's go next. And what is super nice in ROS is that you already have this very advanced behaviors available. So the behavior I will be showing you right now, it is really hard to do your own, because we will be localizing the robot on the map, just know where it is on the map, and we will be also asking the robot to move to a particular place. So it not only needs to know where it is, but it also needs to somehow plan to go from one point to another. And in the ROS, it is just, couple of commands. So I'm starting right now the so-called navigation node. It is a couple of programs. You can see that there is a map. So I loaded the map of the robot. I need to initialize this. So I initialize this navigation by providing the robot with its approximate position. So what I'm doing right now is that I'm just sending, you are probably around here. And when I do that, I can start navigating the robot. So this code actually asks the robot to go to this place. So it will go to around the last of these long pillars. So let's see whether it goes to after the pillars. The robot is behaving strangely because it has to localize itself. So first what it does, it goes around to try to analyze where exactly it is and how it is positioned. It actually failed because we were rotating the robot, so he had a hard time localizing itself. But let's play it again. Maybe this time he will succeed. If not, we can actually help a robot a bit by putting his approximate position. And once again, asking him to go. And the robot is actually navigating itself to this point. So yesterday there was one presentation when the presenter was worried about a live demo. So with robots, live demos are much more stressful because you have a lot to take care of. But at least with simulators, nothing will crash. So the robot actually achieved the position, and you can use the same interface as before. I tried to change the code very little from the one before, that you can also receive the feedback from the robot while it is going. So we have the action client, very similar to the one for the rotation. And with this, we will also ask the robot for the feedback during the call. So we are asking the robot to go to a particular position, and we can actually look at the robot while it is going to this position. The position is very near the previous one, so it will take just a little bit of time, but it has to rotate. So right now what the robot is doing is that he has both to localize itself, it has to plan its own movement, and it is also sending us the data, sending us the back data. The information you see on the screen is actually parsed through OpenCV. So for those of you who know what OpenCV is, you can easily add some new functionalities to this robot. So it can, for example, react to colors. It can, for example, you can put some neural network on the top of that. This is up to you. But what I wanted you to show is that the whole basics of the functionalities can be put on a one, like kind of long, but one Jupyter presentation. Sorry. Okay, so let's stop the event loop, and you can see that it accepted the goal and it reached the position we wanted. So to wrap up, robots are kind of complicated, but it also makes them fun. There is really a lot to do and to explore. What I wanted, this is a Python conference, and I think some of you wanted to hear this presentation because they are interested in robots, but other of you may find it very useful to use robots as a way to learn Python. So you have this ROS tool, which is based on a modern ROS with all of the modernalities, I would say. So you can actually learn and become a better programmer by having this fun play field. But also, if you are interested in robotics, ROS is an excellent tool, an excellent helper, because you have all of these basic layers already built for you. So it is like a really good fundament, a really good base for your future developments. And the third point I wanted to make during this presentation is sometimes people say that ROS is really difficult and that learning curve is extremely high. And it is, but if your approach is open-minded and you have Jupyter Notebook in front of you, I think it is manageable. You have also a huge community of people who can help you, and they really do. Like you have Stack Exchange for normal developers, and for ROS developers, there are ROS answers, and people are really much friendlier there. So I encourage you to play with ROS. You can spin this container on your own computer in a matter of minutes. Please ask me questions if you have problems with that on Discord. And you can start playing, for example, try to make a heart with a turtle sim. I tried to actually make heart, but I failed. So please do it better. And if you're interested in, I would say, a bit more serious robotics, we can talk about using robots and ROS for robotics in rehabilitation. And if you're interested in using machine learning and artificial intelligence in retail, we can also talk about this. So thank you very much. I'm open to questions now.
Okay, thank you, Igor, for your really impressive presentation regarding the ROS and the possibilities that it allows. And I really like the educational part in your presentation, that people can use it for learning Python. Let's see what are the questions. There's a question. The first one is, OpenAI Gym is also used for reinforcement learning simulation. Is ROS based on that?
So actually, OpenAI Gym can be used with ROS. They actually use a closed simulator. It is called, I think, Mujoko, or it is a simulator that you have to pay, especially if you want to use it commercially. Here, I say I use Gazebo. Gazebo is based on something called PyBullet. So the simulator is actually a Python-based simulator. But there are many people who, for example, contribute to AI Gym, and they are also ROS developers. This is like pretty much the same field. But I would say that ROS is much older than the AI gym. We are talking about like 15 years of development and couple of years of development. But I myself also played with AI gym. It is a fun way to play around. But I would say the ROS and ROS framework is much more mature.
Okay. Actually, I don't see any more questions, so I guess we will move with the further questions to Discord. There's already a discussion regarding logo language. Okay, there's a question from Piotr. So I wait a second. What kind of rehabilitation you are mentioning at the end of the presentation?
I'm leading a team right now for hand rehabilitation. So we are building soft robots for people after stroke and also people with neuropathy, but for rehabilitation of hands. We want to make the robots programmable by therapists in a way that it can help the best option, and also to make the robots design accessible particular, so I would say personalizable. So we are trying to make robots that fit particular person or patient needs. And I think it can be a great fun for people who are interested in programming. Also on a level that are learning. So also, Philip, your comment about learning. I know many people who started learning Python because they wanted to use ROS, and now they are Python developers. So it is like a gateway drug for some people for Python, because it is such a fun way to use Python.
Sounds fantastic. Very, very happy to hear that. Okay, I see no more questions, so thank you for your presentation. It was really interesting and inspiring for me as a person who also deals with the education. And now we will end today's of the...
Okay, thank you very much.